Today we are going to find the value of and simplify expressions with exponents. Today you will look for and express regularity in repeated reasoning when you look for patterns and follow those patterns for every single problem. Now let's find the value of each of these expressions and look for a pattern. So 3 to the 4th would be 3 times 3 times 3 times 3. So that's 9 times 3 times 3, which is 27 times 3, which is 81. So 3 to the 4th is 81. 3 to the 3rd is 3 times 3 times 3, which is 9 times 3, which is 27. 3 squared is 3 times 3, which is 9. 3 to the 1st is just 3. So now let's look at this pattern, and like we have noticed in the past couple of days, as you go down this list, all you're doing is dividing by 3. So 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Remember that anything to the 0 power is 1. So 3 to the 0 power equals 1. Now let's continue this pattern. So 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. 1/9 divided by 3 is 1/27. And 1/27 divided by 3 is 1/81. Now, like we saw in class the past couple days, 3 to the 1st and 3 to the negative 1st are inverses. So 3 to the negative 1st is actually 1 over 3 to the 1st. Same with 3 to the 2nd and 3 to the negative 2nd. 3 to the negative 2nd is actually just 1 over 3 to the 2nd. It's just the inverse of 3 to the 2nd. Same with 3 to the negative 3rd. It's 1 over 3 to the 3rd. And 3 to the negative 4th is 1 over 3 to the 4th. So notice that these are inverses, but also notice that the negative exponent makes the value move to the denominator and the exponent becomes positive. So if you have a negative exponent, invert it, creating a fraction, or if it's in the denominator, moving it to the numerator, and then make the exponent positive. So a negative exponent does not make the value of the number negative. That's a very important concept. Just because you see that negative does not mean that the value of that number is negative. However, a negative exponent is the inverse of the positive exponent. And that's what we were just talking about, how 3 to the negative 1st is the inverse of 3 to the 1st. So it's 1 over 3 to the 1st. So if we look at a number like 2 to the 7th, let's make sure we have the correct terminology when we're talking about this. The 2, which is the big number, is the base. So if I ever say the base, you should know that I'm referring to that number. And then 7 is the exponent. So whenever I say exponent, know that that is what I'm referring to. So now let's go through a couple of examples. Let's go ahead and find the value of these expressions. So 8 to the third, we can go ahead and write that out as 8 times 8 times 8. 8 times 8 is 64. Bring on down that times 8. And 64 times 8 is 512. The value of these numbers is always going to be either less than 0, between 0 and 1, or greater than 1. So when we figure this out and we give a reason why, we need to look at two different things. We need to look at the base and we need to look at the exponent. So on 8 to the third, the value of that number is 512, which is greater than 1. And this is because the base is positive. Now let's look at 5 to the negative third. That's the inverse of 5 to the third. So I'm going to write it as 1 over 5 to the third. And then 5 to the third is 5 times 5 times 5, which is 125. So the value of this number is 1 over 125. So 1 over 125 is between 0 and 1. And this is because the base is positive, so the value of this number is positive, but the exponent is negative, so the value of this number is less than 1. Notice that that's a friendly exponent because the negative 4 is included inside those parentheses. And we have a negative exponent, so it's an inverse. So let's go ahead and rewrite this as 1 over negative 4 in parentheses to the positive second. Negative 4 to the second is negative 4 times negative 4, which is positive 16, and then 1 in the numerator. So the value of this number is 1/16, which is between 0 and 1. It's between 0 and 1 because the negative is included in the base and the exponent is a negative even number. Now realize if this exponent had been odd, we would have had a negative times a negative times a negative, which would have made this value negative. So that's why it's important to notice and write down that the exponent is even. All right, now we have negative 4 to the negative second, but this is not a friendly exponent. The negative is not included, so you need to make sure you're very careful when you're working on these problems. Make sure you pay attention to your negatives. All right, so our exponent is negative, which means it creates an inverse. So we have negative 1 over 4 to the positive second. 4 to the second is 16, so this value is negative 1 over 16. So this product is less than 0 because the negative is not included in the base, and the exponent is a negative. Once again, I want to remind you to make sure you pay attention to those negatives because that makes a big difference in your answer. You need to make sure you're being precise. You're being very careful. Now let's move on to multiplication and division with exponents. One thing you need to make sure of is when you multiply and divide numbers that have exponents, you only multiply and divide like numbers. So the base has to be the same. The first thing you want to do when you're multiplying or dividing with exponents is you want to either you need to move your numbers that have negative exponents. So if you have negative exponents in the numerator, you have to move them down to the denominator. If you have negative exponents in the denominator, you need to move them up to the numerator, and then you can multiply or divide. So let's start with multiplication. One thing you need to know is the product rule, which is when you multiply numbers with the same base, you add the exponents. So let's go ahead and do 3 to the third divided by 3 to the negative second. So even though there's division going on right now, once we move that negative exponent up into the numerator, we're going to be multiplying, and we can use the product rule. So, like I said, we have a negative exponent in the denominator, which needs to move up to the numerator. So I have 3 to the third in the numerator, and once I move 3 to the negative second up to that numerator, it becomes 3 to the positive second, and I'm multiplying them. 3 and 3 are the same number, so I have like bases, so I'm going to add the exponents. 3 plus 2 is 5, so that's my new exponent, and then I keep the same base. So this is 3 to the fifth, and we can go ahead and calculate that out and find that it's 243. Once again, let's answer this question. This product, 243, is greater than 1, and this is because we multiplied numbers that had positive bases in the numerator. Next, let's take a look at m to the third times n to the negative second divided by m to the negative seventh times n to the fifth. So the first thing we want to do is move those negative exponents to make them positive. So I have a negative exponent there and a negative exponent there. So I want to move the n down and the m up. So when I rewrite this, I have m to the third in the numerator, and I move that m to the negative seventh up to that numerator and make it positive. I have n to the fifth in my denominator, and I move that n to the negative second on down to that denominator and make it positive. Now I have like bases. So even though I have multiple variables in this, my m's and my n's are both like bases. So I'm going to end up having two different variables in this problem. And that's okay. All right, so I'm going to start with my m's. So right now I'm just looking at that and I'm multiplying them. M is my like base, so I'm going to add my exponents. 3 plus 7 is 10, so that's my new exponent, and my base is still m. And now I'm looking at the denominator. I'm looking at n to the fifth times n squared. N is my like base, so I can go ahead and add my numerator, add my exponents. 5 plus 2 is 7, and then n is still my base. This is all I need to do for this problem. And because we have variables, we do not know what the value of this product is, so we can just write unknown because we do not know the value of the variables. Now let's move on to division. Our quotient rule is similar to the product rule, except now we're dividing. And when we divide numbers with like bases, we're going to subtract the exponents. So when you multiply, you add, and when you divide, you subtract. So let's go ahead and try this out. We have 3 to the 9th times 3 to the negative 5th, which this one looks like multiplication, but we have that negative exponent. So the first thing we need to do is move that to the denominator. So in the numerator, I have 3 to the 9th still, but in the denominator, I have 3 to the 5th. That 5 becomes a positive exponent once I move it down. So now I'm dividing with like bases. 3 is my like base, so I'm going to subtract the exponents. 9 minus 5 is 4, so my new exponent is 4, and my base is still 3. And I know that 3 to the 4th is 81, so I'll go ahead and calculate that out. We know that this product is greater than 1, because 81 is greater than 1. And this is because our base is positive and our exponent is positive. I have one more, and this one includes variables, just like the example using the product rule did. Don't be scared by the variables. Just move your variables that have negative exponents and then add or subtract the exponents. That's all you need to do. It's okay if you do not come out with a number as your answer. For x to the 10th, y to the negative 2nd, x to the negative 3rd, y to the negative 1st. The first thing I want to do is move all of my variables with negative exponents down to the denominator. So that one's moving down, that's moving down, and that's moving down. So when I rewrite this, x to the 10th is the only thing left in that numerator, and everything else is in the denominator. Y to the positive 2nd, x to the positive 3rd, and y to the positive 1st. Now that 1 does not have to be there, because y by itself would have an understood 1 as an exponent, but it will help if you keep it there for now so that you can more easily add your exponents. So first, let's look at our x's. We have x to the 10th in the numerator and x to the 3rd in the denominator. We're dividing, so we're going to use our quotient rule, which says that when we're dividing numbers that have the like base, which is x, then we're going to subtract the exponents. So my exponents are 10 and 3. 10 minus 3 is 7. It's positive 7, so it's in the numerator, and x is still my base. I have y squared and y to the 1st in the denominator. So I'm multiplying, but I'm multiplying in the denominator. So my answer is going to stay in the denominator. Y squared times y to the 1st. Go ahead and add those exponents. So 2 plus 1 is 3. So my new exponent is 3, and my base is y, and that stays in the denominator. I'm done with this one, and just like the example using the product rule, the product of this is unknown because we don't know the value of the variables.